Hello and welcome to PhaestusFox does Adventive Code. In this video, I'll be doing day 1 and 2 of the Adventive Code. For those of you who don't know what the Adventive Code is, it's a bunch of programming challenges related and laid out as an advent calendar. So you get 2 challenges each day. One unlocks when you complete the second one. One unlocks when you complete the first one. And I've decided this year to relate it to my channel. I'm going to try and have like Bevy implementations for each of the systems that renders some kind of novel approach. Since the Adventive Code has a story built in, I've decided to use that as the schematic and scaffolding for the visuals that I generate for each event. Anyway, the way I'm going to lay this video out is I'm going to read the synopsis and story for day 1, then I'll show you my Bevy implementation for day 1, then I'll go back and do day 2. Okay, so Santa's reindeer is typically a reindeer food, but they need a lot of magical energy to deliver all the Christmas presents. For that, their favorite snack is a special type of star fruit that only grows in the deepest jungles. The elves have brought you on their annual expedition to the grove where the fruit grows. To supply enough magical energy, the expedition needs to recover a minimum of 50 star fruit by December 25th. Although the elves I assure you there'll be plenty of fruit in the grove, you decide to grab fruit along the way, just in case. Collect stars by solving puzzles. 2 puzzles will be made available each day on the advent calendar. The second puzzle unlocks when the first is complete. Each puzzle grants 1 star. Good luck. The jungle must be too overgrown and difficult to navigate by vehicle or across from the air. The elves' expedition traditionally goes on foot. As your boat approaches the land, the elves begin to take inventory of their supplies. One important consideration is food, in particular the number of calories each elf is carrying. The elves take turn writing down on a piece of paper the number of calories from meat, snacks and rations, etc. that they have brought with them. 1 per line. Each elf separates their inventory from the previous elf by leaving a blank line. For example, they have this, and they explain how you would read this out using that information. And they basically say that the elf with the most calories is 24,000. So it asks us to find the elf with the most calories. For my values that I got given, I got 69,281. And I got that in one shot. For part 2, by the time the answer of the elves' questions, you've already realized that the elf carrying the most calories may eventually run out. To avoid this unacceptable situation, the elves also want a list of the top 3 elves and how many calories they are carrying in total. So that way, if the first one runs out, they'll have 2 backups. In the example above, they got 45,000 as the thing, and then it just asks what is the combined calories of the top 3. And I got 201,552. Okay, on to the Bevy code. I'll start by running my advent thing. I'll explain how the calendar is done, and then I'll go into day 1. So when you open it up, you get this advent. It's all very rough at the moment because I intend to improve it over the time. I just thought if I spent too much time getting it all done, I'm already 6 days late on the advent, so I would never catch up if I had to keep polishing everything out until I released. So until day 25, I can polish things. Anyway, so if you load this up from my GitHub, you will have different number positions, but every time you load it after the first time, the number positions will be the same as previously. So you also get the 2 stars indicating what you've done. You still have to set this manually because I haven't yet implemented it. Gray stars mean that you haven't done them yet, and black stars mean that that day is not yet unlocked. If we then click on day 1, it will show us each elf, which is randomly generated from a selection of hats, bodies, heads, and legs. At the moment, only have 1 body and 1 head, but their hats and legs are different colors randomly. And then it shows you what rations they have. Again, this is randomly generated, but consistent once generated. So my last elf will always have the eggplant. And these elves are the elves that at some point ended up in the top 3. And so you can see some just packed a single thing and it was worth a hell of a lot, like this ridiculous eggplant. And others packed a variety of things. And this was just about adding some flavor and flair. In theory, over the time with polishing, I will hopefully make these bigger and not overlap the elves as much, but I've already struggled with this enough over the day of making this. So, into the code, just quickly going over the advent, it loads up all the assets into an advent asset, which also, there's the advent data, somewhere in here, advent data, which contains the random seed, the stars you've done, and what day it currently is to display the grayed out stars. And then it lets you check whether it's gold or not. And then I just spawned 25 boxes from 0 to 25 and then randomize them with that seed and then spawn them in and like align them with rows and columns of the correct width. And then that's all the advent really does. The advent is spawned when you enter calendar menu state, which is the default state of the game. There is also a state for every day. The buttons hold what state they point to. So when you click the button, it will enter that state. I then have the days module, which when you start up and add as a plugin, it will initialize the days, which will load all the day data up so that it's loaded when you go into the specific menu. It also has a const generic function here for spawning a specific day's title, and also a cleanup method for getting rid of that data that's loaded. This makes the flex box so much easier to interact with because it doesn't mean you have to keep track of what other things might be loaded. Anyway, on to day one. This has a system set that's run when you enter and a system set that's run when you exit. It also instantiates a resource of rations, which is just all the images of food. So it spawns day one when you enter state one, and then it reads data, which is the thing that generates and returns in the console the answers and displays on the screen the little graphics that I've decided to do. The rations thing is just a vector of handles of images that is loading a file and converting them. Very simple stuff. Elf data is a list of all the elves. The elf rations, which is just a list of the food that they're carrying, which is the rations themselves and their total. And the minimum and maximum size of the individual rations, which is used for calculating how wide to make each food sprite's range that it can be. When we read the data, we get a handle for the day and then read the day from the day's asset. It contains the title and the value of the data. Once we've loaded the day, we then create a new elf data, get our seed that allows for our pseudo-random numbers to be consistent between running of the system, but random for each individual person. We then generate an elf randomly with that seed. We then let the current elf equal an elf rations default. We go through each line of the file, trim the line for safety reasons. We then check if the line is 0 length. If the line is 0 length, we insert into the elf data the current elf with its ID. We then increment the seed by 1 and create a new elf and continue. If the line is not blank, we pass it assuming that it's a valid string, so we just unwrap it, and then we add to the current elf that ration. And then finally, once the loop is done, we have to make sure that we add that final elf onto the list because it won't have a new line after it. We then make a vector of the children, which is basically each elf and its food will be in a row on our screen. Then we let the range, which is how wide each ration sprite, like how many values fall into that particular ration. So that's just the maximum and the minimum sized ration. So the biggest and the smallest ration divided by the number of rations we have is the space between each ration. And then we set our 3 most, second most, and third most, and then iterate through each elf. If the total is greater than the third most, we add that elf to the list and also render it. And then if it's bigger than the second, we set the third equal to the second, because we know that it's going to be bumped down 1. And then if it's bigger than the first, we set the second equal to the first, because again, we know it's going to be bumped down 1. And then we set the most equal to the total. Otherwise, we set the second most to the total, because we only bumped the third. And then, or we just set the third to the value, because we didn't bump any. Okay, then we get the elf starter. We let the elf ID, and then we draw it. This will then draw the elf to the screen with the specified scale, which then we attach to our column, which is each row, or each column, gets an elf put at the beginning, pushed as a child here, and then we spawn, when we iterate through all the rations, and then we work out the ration index, which is the ration minus the minimum size divided by how big each ration is, and then we select that ration out of the ration set and spawn it with being 25 by 25 pixel size, and we justify content from the start, making this 100% wide and 40 pixels high. So this is just all about laying out content on the screen, and then we push all those children into a list. Then down here, we spawn a large object that's 100% by 100% of the screen and 100 pixels down. And then we simply spawn all the children underneath that, or attach all the children underneath that, and print out our results, which you can see in the console. And so the first one is first question, the second one is the second question, and that's all you need in order to render it. I was originally going to render it, like animate it, but Bevy had a problem with having a system set running on enter and on update. It decided it couldn't work out which one to run first and would just lock up and block the whole system. So I had to render it in the scene that I generated it. But hopefully I'll be able to work around that and have animations and polish later on. But that's all to be implemented in the coming days. Anyway, on to day 2. So the elves begin to set up their camp on the beach. To decide whose tent gets to be closest to the snack storage, a giant paper, scissors, rock tournament is already in progress. Paper, scissors, rock is a game between 2 players, each containing many rounds. In each round, the player must simultaneously choose one rock, paper, or scissors using their hand shape. Then a winner of that round is selected. Rock defeats scissors, scissors defeats paper, and paper defeats rock. If both players choose the same, then it's a draw. Appreciative of your help yesterday, one of the elves gives you an encrypted strategy guide, your puzzle input, that they say will be sure to help you win. The first column is what your opponent is going to play. A for rock, B for paper, C for scissors. The second column, suddenly the elf is called away to help with someone's tent. The second column, you reason, must be what you should play in response. X, Y, X for rock, Y for paper, Z for scissors. Winning each time would be suspicious, so the responses must have been carefully chosen. The winner of the tournament is a player with the highest score. Your total score is the sum of your score for each round. The score for each single round is the score of the shape you selected, 1 for rock, 2 for paper, and 3 for scissors, plus the score outcome. So 0 if you lose, 3 if you win, and 6 if you win, 3 if you draw. Since you can't be sure if the elf is trying to help or trick you, you should calculate the score you would get if you were to follow this strategy guide. So then it explains how you would calculate from the example and saying you'll get 15. I did that on my numbers and got 11,150. Okay, then we move on to the other thing. The elf finishes up helping with the tent and sneaks back to over here. Anyways, the second column is how the round should end. X means you need to lose, Y means you need to draw, and Z means you need to win. Good luck. The total score is then changed, so the score is calculated the same way, but the actual total will be different. So for the same example above, now you only get 12 points. I then modified my code and then got a total of 8,295. If we move over to the Bevy code, and I scroll up, so it starts off the same by spawning the day and calling read, but when we enter day 2 instead, and when we exit the day, cleaning up. It uses hands instead of rations, which is the same thing, but not randomized. So just 3 sprites, the pot, rate, rock, paper, scissors are stored in that. I have a strategy guide, which has a list of the moves made and then the total score accumulated. And then we have functions, say play move, which works out the outcome by using your move against their move. And then the total score is the outcome of that plus your move. And then we push the move onto the list. Quickly before we go through the actual calculating. The outcome is win, which equals 6, draw equals 3, lose equals 0, which is the number of points. And same with the rock, paper, scissors. Then in move, you have versus, so you put a second move in, and then there's just basically a lookup table of how that would result. So draw, win, loss. And then in against, there's the same thing where you specify that I want to win against rock, and it will tell you to play paper. Same, just a lookup table, allowing Rust to affirm that every possible combination is checked, rather than writing some kind of complicated logic, like if the values are the same, it's a draw, or if you want to draw, return the same value. Instead, it just tells you every possible combination. Okay. Finally, up here, we do the same thing as the previous day, loading up the day's data. Then we start 3 strategies. We have game 1 strategy and game 2 strategy, being the telling you what move to play and telling you what result to get. And then just for having even more data, I've got a perfect game, which will always pick the perfect outcome. Then for each line, we trim it and get the first value. If it's an A, we return rock, B, paper, C, scissors. And then on the same thing, we get the last letter, and we return your move, and then for both game 1 and game 2, which returns rock, paper, scissors accordingly, and outcome loss against their move, draw against their move, and a win against their move. Then we go down here, and on each of the games, we play the corresponding move. The perfect game will always have the outcome win against their move. I then print out the scores, 1, 2, and the perfect game. So that's in the console when I run it, you'll see what your result will be. And they can be entered into the advent of code to get your start. I then have skip games, which is just about reducing the number of games to display on the screen. Otherwise, the hands need to be really small or they overlap a lot. I then have 4 sets of children, which is each game and their moves. So then I have some constants to allow you to change the size of the hands without needing to rewrite it everywhere. A constant style here, which takes in the hand size and how to justify the content. I then spawn the hand with the style and the appropriate hand. So that's just hands.get, and then so for the first one, their hand or their move, and then I attach text with the index of the game. This is just about allowing you to sort of cross-reference which game has which corresponding hand in the 4 columns. I do that for their hand and the 3 hands that you could play in response. I then have a style for the columns, which are set to being 25% of the width of the screen and 85% of the height. Again, fixed at 150 pixels below, just so they don't overlap the title. Then from there, I spawn each one, attach the corresponding children, and then increment the position 25% across, spawning the 4. From that, we result in the day 2 advent, which if we go to 2, and we have to full screen it, because again, it's missing a lot of polish, so the hands overlap when you're in a too small of a screen. But this shows what hand was played in each game and how you could have differently played it. So for example, they played rock in the strategy 1, or you play scissors, which would be a loss. But in strategy 2, you'd play paper, and in the perfect game, you'd play paper. And then if I reminimize this, you can see here are your 2 numbers that you need to enter into the advent of code. I hope you've enjoyed this video, and I will see you in the next one. So do like, comment, subscribe if you want to see the rest of the Advent of Code stuff, and I will continue trying to come up with fancy little graphics to represent, like just a data representation of some of this challenges. I hope to see you there.